Hello everyone, welcome to Saimedha Koti, Hyderabad. Let us solve the network questions. The question number 4 is the power delivered by the voltage source as a function of the A is. So this is given network. Option 1 is a V square by R. Option 2 is a 1 minus A V square by R. Option 3 is 1 plus A V square by R. Option 4 is a minus V square by R. So this given network, just identify the principal nodes, just apply the KCL at this node. So let us assume node number 1 and node number 2. So by KCL equation, at node 1, so node 1 the KCL equation, so we get, so algebraic sum of the currents at a node is equal to the 0. Incoming current, this is outgoing current and this one is incoming current. So that is, let us consider incoming current is minus sign. So minus I, the plus, okay, I1. So minus, okay, here A I1. So is equal to the 0. So therefore I is equal to, so here 1 minus A times of I1. So this one is the 1 minus A times of I1. Where I1 can be written as, okay, see this one I1, we know the voltage, okay, plus sign, the minus sign, so that therefore I1 is equal to the V by R. So now this one is I1 is equal to 1 minus A, so V by R. So now we required the power in the voltage source, okay, it is equal to V voltage multiplied by current. So in this branch current is equal to I. So therefore V 1 minus A the into V by R. So this is equal to the 1 minus A times of V square by the R. So that option, 1 the minus A, so minus I1, so 1 minus A times of V square by R. So that option, okay, 2 is correct for this question. Let us solve the question number 5. The question is network has n nodes, I independent loops and number of branches in the network is. Option 1 n minus 1, option 2 I plus n minus 1, option 3 n plus 1 and option 4 I plus n plus 1. So independent loop means number of the meshes. So we know that the number of the mesh are independent loop, so is equal to, so where m is equal to, so this one you can write B minus, okay, n plus 1, where B is a branch, n is the number of the nodes and this number of the mesh independent loops is given I is equal to B minus n plus 1, but we required B. So our B is equal to I plus n minus 1. So what is the answer? Option that 2 is correct for this question. Let us solve the question number 6. The H parameters of the following circuit shown below. So this is the circuit, only shunt branch is given. So directly also we can answer, that is H is equal to 0, 1, minus 1. Otherwise we can answer like this also. So we know that H parameters, the dependent parameter is the input voltage and output current. So input voltage is the V1, the is equal to H11 I1 plus the H12, okay, here V2. So and I2 is equal to output current, the H21 the into I1 plus the H22, okay, V2. So this is the dependent parameters, I1 and V2 are the independent parameters. So to find H1, so what we have to do, the H1 is equal to, so here V1 by I1, so when V2 is equal to, so this one is a V2 is equal to the 0. So that means V2 is a 0 means it is a shorted. When it is a shorted, what is the resistance value? V by I is nothing but resistance. So now we need to find out the resistance value. So what is the, this value is equal to 0. These two branches will become parallel. So 0 into parallel something, so that will become, so it is equal to the 0. So now H1 parameter 1 is equal to the 0. And next one H21, H12 is a required. H12 is equal to the V1 by, okay, V2. So this V1 by V2 and I1 is equal to, so this I1 is equal to the 0. So that means I1 is equal to 0 means it is a open and this V1 by V2 is equal to, we will get the same, the 1 ohm resistance. So now it is a voltage gain, so this here we will get the 1. And next parameters, okay, H21 is a required. So how do we get H21? By shorting this one, make it is 0. So therefore H21 is equal to, so I2 the divided by I1, and V2 is equal to the 0 when V2 is equal. So this is the current gain. So now here we will get same resistance, 1 ohm resistance. So now V2 is equal to 0 means, okay, it is a short. So now this one is a only voltage gain, V2 is equal to V2 is equal to minus 1. Why? Because this current is a required, but this one is the opposite direction. So that's why it is equal to minus 1. And H22 is equal to, so H22, so here I2 divided by the V2 when I1 is equal to the 0. I1 is equal to 0 means that it is a open circuit, so that admittance is equal to the 1. So that, so answer for this question, so 1, 0, 1, and next one minus 1 and 0. So answer is option the 4 is correct for this question. Let us solve the question number 7. The question is, which of the following statements are wrong with respect to the 3-phase system? RYB in the clockwise phase sequence. This is also called positive phase sequence. And in a balanced system, line currents are 30 degrees beyond the respective phase current. In balanced star system, line currents are 30 degrees beyond the respective phase currents. In a balanced star system, line voltages are 30 degrees away of the respective phase voltage. In the balanced delta system, line voltages are behind the respective phase voltage. So we need to find out the wrong statement. So now let us see the first one. So per star connection point of view, so in the star connection, so we know that the line current is equal to, so this is the star connection, always line current is equal to the phase current, okay, in the star connection. But what will happen in the line voltage? Okay, this one is the, let us see the per RYB phase sequence, okay, RYB or the ABC phase sequence point of view. So now voltage in the phase voltage in the R phase voltage, the here this one is the Y phase voltage, and this is the B phase voltage, okay, phase voltage is here RYB phase voltage. Now this one we can say that the phase voltage, okay, V phase valve, and we required line. So this one is the line, that to find out the line, that is the minus VB, minus VB, vector sum of these two. So we will get, okay, this voltage, and now this one is R, next to line voltage we can get, so Vy, so minus Y Vy, so vector sum of these two we will get the line, so VRY. So it is a line voltage valve. So this line voltage that is equal to √3 times of the phase voltage plus 30 degrees, that is this angle is equal to 30. So that means line voltage leads the phase voltage by 30 degrees. So that is VL leads, okay, the V phase by 30 degrees, the per positive phase sequence or clockwise phase sequence. And this is the correct statement. So just verify this statement. Next one, and next one is another one is delta connection. So given that delta connection, so in the delta connection always the line, this one is the line voltage is equal to the phase voltage, but line current is equal to, so this line current, so always the √3 times of the phase current, okay, phase current, at an angle of the lagging condition. Just verify, suppose if it is the VRY voltage between the line and this one, the IRY, and this one is the YB current in the YB phase line current, and this one is, okay, BR current in the BR phase. So now this one is the minus IBR. So now vector sum of these two, so we will get, so that is a phase current. So this phase current IP that is equal to √3 times of the line current, the minus 30 degrees, that is a lagging position. Now first statement, see, in balanced delta system, line currents are 30 degrees behind the phase current, And next one, in the balanced star system, the line currents are 30 degrees behind the phase currents. Now these two statements, okay, first second statement, and this one is the wrong statement, and this is also wrong statements. Okay, here this one is line voltage is equal to the phase voltage, there is no phase displacement, so it is the wrong, and this one is the wrong, and these two are the correct statements. So that option, the 2 and 4 are correct, 2 and 4 statements are wrong, so that option 2 is correct for this question. Let us solve the question number 8. For the circuit shown in the figure, the potential difference between the point x and y, Vxy, is all resistance value are in the ohms. So this is the given circuit. So now first one, let us assume the current in this loop is a I1 amount of the current. Okay, I1. So what is the value of I1? Voltage divided by equivalent resistance. So that is a 2 by 5. So current entering position, so that it is a positive sign, and this always in the passive element, current enters at the positive terminal and leaves at the negative terminal. And what is the voltage across this branch? So 2 by 5, so this is equal to 6 by 5 volts. Now similarly in this loop, let us assume current is equal to I2, where I2 is equal to voltage is a 4 and total distance is equal to 8. So it is equal to 2 by, so this one is, okay, it is equal to 1 by, okay, 2. So we got 1 by 2. So current is equal, current enters at the positive terminal line, the leaves at the negative terminal. Now what about this voltage? Okay, that is equal to the 6, this one is a 1 by 2. So now this is a current, the 3 ohms. So that is equal to 3 by 2. So volt in this branch. Now apply the KVL. Okay, this one is apply the KVL in this, okay, up to here. So therefore Vxy is equal to, so voltage between the x and y points. So that is minus, okay, this one is a minus the 6 by 5, okay, minus, okay, this minus 4, the plus, okay, here 3 by 2, this is equal to Vxy. By solving this we will get minus the 3.7 volts. So it means that, okay, Vxy is equal to minus 3.7. So therefore Vyx is equal to 3.7 volts. Now Vy is greater than, okay, greater than the Vx. So that means Vx is a lower potential. First one, see, x is higher potential of 3.7 volt with respect to y. So this is the wrong. And next one, x is the lower potential of 3.7 volts with respect to the y. So that option, that 2 is correct for this question. Let us solve the question number 9. The question is, find the current ID flowing through the diode and voltage across the VAB in the circuit shown in the figure. Assume diode is ideal. This is the given circuit. So now we required the diode current. So suppose if it is diode is conducting, so this will become, so this one is, okay, diode is a conducting, so it is a act as, okay, it is a simply, it is the diode current ID values, and this resistance, okay, this I am converting this source, and this resistance is the 4, and suppose this resistance is the 4, I am source transformation, just I am applying the source transformation here. So now this current is equal to 10 by the 4, so it is equal to 2.5 amps. Now this is the given circuit. So diode current is I. Now here I am applying again source transformation. So this voltage will become, so this resistance R, and the voltage is equal to plus and the minus, okay, it is a 2 volts. Now this is the circuit, and again here this one is the 4 and this is the 4 ohms. So now it is equal to, so by some, this is a parallel connection, so that equivalent R equivalent is equal to, so here R equivalent is equal to the 2. So now this is again by transferring the source transformation plus and minus, now it is equal to the V, so 2.5 into 2, so that is a 5 volts, and this current you can say that ID current, and this resistance is a 1 ohm. So now here 1 ohm. So now already I have given the terminals, okay, this voltage, so this one is resistance here, okay, it is a 2 ohms. So now this one is the 2 ohms we have. So now this is a okay, here 2 ohms we are connecting, and by transferring this one is a 2 ohms and it is a 3 ohms. Okay, this one is the short. Now what is the current passes through here? So current is equal to, so now this voltage is a 2.5 and it is a 4. So now it is equal to the 2 ohms of the current. So now simplify now. So now here 2 volts is there. So 2 volts plus and the minus, it is equal to the 2 volts. Now this value is equal to current passes to the diode, current is equal to difference of this voltage. So now that is a 5 minus 2 divided by total distance is equal to the 3. So that is the 3 by 3 is equal to the 1 amps. So we can get the current passes the diode is equal to the 1 amp. Now suppose if it is diode is a conducting, just apply. So here the binodal analysis. So binodal, so we can get, so that is V minus okay 10 divided by 4 plus V by 4. So voltage across the VAB. I am consider that this one is the one principal node and this is the ground. So now this current is equal to the here complete, this is the one node. So now here plus V by 4. So minus 2 is equal to the 0. So V by 4 and V by 4, V by 2. So now this one is the V by 4 and this is the V by 1. So now here, so 3 by 2 times of the V is equal to 4.5 times of the voltage. So by solving here, so V is equal to the 4.5 divided by 1.5. So it is a 1.5 volts. So now this 3 times voltage is equal to the 3 volts. So answer is, so 1 amps and the 3 volts is the right answer for this question. Okay, here just when it is conducting, current passes to the diode. So just by using source transformation we got this diode current that is equal to 1 amps. Let us solve the question number 12. The question is the equivalent inductance of the network shown below. These 3 inductances are given and which are mutually coupled. Answer 1 is a 60 by 9 and option 2 is a 9 by 16, option 3 is 50 by 9 and option 4 9 by 15. So per parallel mutual coupled inductors, okay, this L equivalent is equal to 1 by L equivalent equal to 1 by L1, the plus 1 by L2 plus 1 by L3. So plus 2 times of the M12 the into L1 L2, the plus 2 times of the M23 the divided by L2 L3 plus 2 times of the M31 divided by L1 L3. So this is the formula for the parallel the coupled inductors, parallel coupled the inductors. So this is the L equivalent formula. So let us consider this one is a L1 and this is a L2 and this inductance is a L3 and this one is here M12 and this one is a M23 and this is M31. So mutual coupled inductance between third coil and the first coil. Now let us substitute all the values in this equation. So we will get, so 1 by L equivalent we have to find. The L1 is equal to 1 by 25, the plus L2 is equal to 1 by 30, the plus 1 by 35, the plus 2 into M12. M1 is the mutual inductance between the first coil and the second coil. So into 10 divided by L1 L2 is a 25, the into this 30, the plus 2 into M23, the coil 1, 2 and 3, the 15 divided by L2 is a 30 into 35. So plus 2 into M13 that is 10, the L1 is so this 25 and L3 is a 35. So this one is the 35. By solving this we will get, so 1 by L equivalent is equal to, so 9 by the 50. Okay, this one is a 9, but we required L equivalent is equal to, so this one is a 50 by the 9. So answer for this question option the 3 is correct for this question. And next one, let us solve question number 13. In the RLC series circuit, the R is equal to 230 ohms. Here given that R is equal to the 230 ohms and frequency of the main supply. So here V is equal to 230 volts, 50 hertz respectively, and taking out of the capacitor from the circuit, current lags the voltage by 30 degrees. Current lags voltage by, that means if capacitor is taken out from the circuit, so it act as a pure RL circuit, so that current lags the voltage by 30 degrees, and taking out of the inductance from the circuit, the current leads the voltage by 30 degrees. So the complete RLC circuit act as a RC circuit, so that current, the capacitive current leads the voltage by 30 degrees. The power dissipation in the RLC circuit is option 1 the 305 watts, option 2 210 watts, and option 3 is a 0, and option 4 is a 230. So when this, under this condition, the XL is equal to XC, so that it is a series, the under the RLC resonance condition, under resonance, okay, conditions. So then what will happen, the resonance, the conditions, so that is power is equal to cos theta, power factor is equal to 1. When power factor is equal to 1, power dissipation is equal to V square by R, or V into I only. So this V into I, that means you can write V square by R, so that V is equal to 230 divided by the 230 ohms. So it is 230 square divided by 230, so it is equal to the 230 watts. So answer for this question, option 4 is correct for this question. And next one, let us solve question number 15. In a 3-phase 400 volts 4-wire system, one incandescent lamp of the rating 230 volts 100 watts connected to the between R phase and the neutral. Another lamp is rating 230 volts and 100 amps connected between the, so this one is a Y phase neutral. The neutral wire breaks, then what will happen? So a 200 watts lamp will fuse first, 100 watts lamp will fuse first, both lamp will glow, both lamps will fuse at a time. So now in this case, first one, in the lamp 1, current I1 is IL1 is equal to, so now power is equal to 100 watts, okay, divided by 230, and next one, lamp 2 is equal to IL2 is a, so 200 watts divided by the 230 volts. So now in this case, okay, by using this you can conclude that IL2 is a greater than the IL1, okay, IL2 is a greater than IL1. So definitely power rating of, okay, this one is a P, power rating of the lamp 2 is a greater than the power rating of the lamp 1. So if the neutral wire breaks, the 3-phase system will become unbalanced. So due to unbalance in the 3-phase system, so this power rating, that means the lamp which has the low wattage will fuse first. So which one? So 100 watts lamp will fuse first. So option the 2 is correct for this question. Okay. So this was the discussion of the network question. I hope you got it. Thank you very much.